Hi everyone, I'm Xiaochang Chen. Today I want to walk you through my loan default prediction project. In the first part, I will tell you how I boosted my model performance. So when we first tackled this problem, we know we need to get creative with our features. You can't just feed raw data into a model and expect magic. So one of the first things I did was create age groups. Instead of treating age as just a number, I split the people into categories like young, mid-age, and so on. This really helped because, let's be honest, the relationship between age and loan default isn't perfectly linear. I also created some financial ratios referred to professor that actually measure what loan officers look at in the real world. Debt to income ratio, basically how stretched someone is financially. Credit history length compared to their age to see if they is new to credit. And loan amount relatively to credit score to gauge if they are borrowing appreciably. And these ratios tuning out to be pretty value signals for our model. Another simple but effective change was switching from label encoding to one-hot encoding for our categorical variables. This way, the model doesn't think a homeowner is somehow greater than renter in some mathematical sense. Now for the fun part. Comparing different models, we tried like 4 main approaches. Logistic regression gave us an F1 score of 0.89, not bad for something so simple. It's super interpretable, which is nice, but it just couldn't capture some of the complexity in our data. Random forest did much better with 0.93 F1 score. It was particularly good at precision for default prediction, about 0.89, meaning when it predicted someone would default, it was usually right. Gradient boosting was similar with a 0.92 F1 score, though it wasn't quite as good as catching potential defaults. But XGBoost was our winner with a 0.93 F1 score and the best balance of precision recall for defaults. When you're trying to avoid bad loans, the balance is crucial. We actually tried to get fancy with an ensemble model too, combining XGBoost, CatGBoost, CatBoost, and logistic regression, but that was kind of disaster. Only a 0.62 F1 score on the test set on Kaggle leaderboard. Sometimes simpler really is better. One of the biggest challenges we're dealing with class imbalance. We had more non-defaults than defaults in our data. We use Smooth to generate synthetic examples of minority class, which is a fancy way of seeing like we created realistic-looking fake defaults based on patterns in the real ones. This made a huge difference, but before Smooth, our model was basically ignoring fault risk. After implementing, we saw about a 50% jump in our ability to catch potential defaults. For our final XGBoost model, we spend a lot of time tuning parameters. We bump up the number of trees to 450 and slow down the learning rate to 0.1 to avoid overfitting, and limited tree depth to 6. Added some randomness with subsample and co-sample rate of 0.9. Add applied regularization to keep things under control. And this tuning gave us about a 3% boost in overall F1 score, but more importantly, a 6% increase in catching an actual defaults, which is really matter from a business perspective. In the next part, I will show you how I evaluated my model. For validation, I kept it straightforward with 18 to 20 training test split. My dataset was large enough that I didn't need to get fancy with cross-validation. And if you look at my learning curve, you can see there is still a gap between training and validation performance. The training score is sitting up like nearly 1, while the validation score climbs from 0.9 to 0.94 as we added more data. This tells us we're still overfitting somewhere, but the trend suggests that more data would help close that gap. The regularization we added definitely helped, but there's still room for improvement. And the confusion matrix is where the rover meets the role from the business perspective. we correctly identify about 96% of good loans. That's great. And we incorrectly flagged about 4% of good loans at risk. Those are missed opportunities. We missed about 17 of actual defaults. And we correctly called about 83% of actual defaults. That's where we saved money. That's 17% miss rate on defaults isn't idle, but it's a reasonable trade-off given the overall performance. About the Kaggle competition results, I should mention that the results, the model to the test in the Kaggle competition, I just placed the 15th with F1 score of 0.85493, not too shabby, and it's interesting that our competition score was lower than our validation score. That's pretty normal. Model always perform better in controlled environments than in wild, and it's a good reminder of why robust validation is so important. What's next? If I had more time and resources, here's what I'd love to explore. And first, external data will be huge. Things like unemployment rates and other economic indicators. More details, credits, history beyond just has default before, and banking transaction patterns that measure someone's financial stability. And for productions, we need a solid monitor set up. Regular checks for data drive. Today's loan applicant fundamentally different from our tuning data, checking off key metrics over time to catch any performance degradation. A champion challenger framework where we're consistently testing potential improvements, automatic triggers for retaining where when performance dip or data changes significantly. So where did we land? Our XGBoost model gives us a solid foundation with that 0.93 F1 score on validation data and 0.85 in competition conditions. Looking at what drives the model's decision, previous defaults dominate everything else, no surprise there. And home ownership status is a distant second, followed by a bunch of other features with smaller contributions. And I think we struck the good balance between approving loans and managing risk, but there's definitely room to get better too at identifying potential defaults. With more data resources and continual refining, I'm confident we can push performance even higher. Thanks for listening. Happy to answer any question about our approach or result.